Okay, in this video we will talk about the first FEM lab, and we will create idealized part and do some meshing. Okay, so here's the schedule. Okay, for the later half of our semester. Then for this lab, first you want to go to the web course, download the CAD we provided. So that's the CAD for you. You want to download this into a download the zip, and that should be on my desktop right now. So you want to unzip everything. There are 3 files inside. Unzip everything into a folder, okay, with the other parts. So this way, once you open the assembly, you would have all parts inside. Then after that, let's start the FEM. And so first we're in the modeling, then we need to switch to advanced simulation. So here now we're in the simulation, but we don't have any FEM and sim. So you want to create a new FEM and a simulation. Of course, you can just create a FEM and create a simulation later. But for now, we just create both. And make sure you have this idealized part clicked. Okay. Then everything should be default. If you have done some thermal, then you need to switch back to structural. Okay. Then this will create the FEM and the sim as well as idealized parts. Then here's actually it'll take you directly to the sim. So we can just say OK. Then we're in the sim. Then take a look in the window. Okay, so we have created 3 files, sim, FEM, and there's this one. It's called idealized part. That's why it has an I in the name. So we're gonna start with the idealized part. So what is idealized part? You can take a look in the slides. Basically, it's a connection between your CAD to the FEM. Because the CAD is for manufacture, you don't want to do any modification on that. But when you do a simulation on a very complicated part, sometimes you need to simplify it. Sometimes if it's symmetric, you can just use half of the model. Okay, but you don't want to screw up with your master CAD. Okay, so the idea of idealized part is you can modify it. That will not affect your manufacture, but it will create this idealized part that will be able to do for you to do simulation on a simplified or idealized. So basically this is another CAD. Okay, let's say that. So first step, we're gonna go to this idealized part, and here you can take a look at the dependency relationship. So the FEM is built on the idealized part. The idealized part is based on your master CAD. Alright, then once we're in the idealized part, okay, first thing you need to do is promote. So for now, this is a one gigantic piece of CAD. There's no information on a single part. You cannot modify it. Okay, this idealized part is considered as a whole piece. So if we want to do some modification, you need to promote the body. And why do we need to modify it? You might heard what Dr. Zarda said in the class, that this is a shell-like structure. So you want to use shell element instead of just use tetra for everything. So those two is going to be shell, and we need to find the mid surface of the shell in this idealized part for the fan. Okay, and for the blades, this portion here it is also a shell-like 2D structure. So we need to cut this blade into two parts. Then for the bottom part, we're going to use the shell elements. Then for the top, it's sort of not regular. It's not shell, not a bean, so we will use 3D texture. So that's the plan, and that's why we need to modify the CAD. Okay, so first we need to promote, and since we're going to modify all four of them, so we will pick the four parts. We will separate them from the whole model. So if you go to the part navigator, you will have four promoted body, and once you promoted them, you will be able to modify them. So the first thing we need to do is find the mid surface for the handles, and that command is right in here in the drop down menu, mid surface. Okay, so first you want to pick a one handle, and the strategy to find the mid face is progressive. Then we just have to click this button, and so once you click that button, it'll generate the mid surface of this shell-like structure. And let's say okay, then you can tell there's a line in the middle and the other one doesn't have it. Okay, so we're going to do the same for the other side. Okay, and say okay. To make sure you can find the promoted body, and just like in your modeling, you can right click and hide one feature. Then as you can see, we have the mid surface of the handle. Alright, so next is split body, right? If we don't consider the blades, those two parts are actually symmetric with respect to XY plane. Okay, and in the FEM, when you do a mesh on a symmetric part, it's better to do a mesh on a half of the model, then reflect or mirror to the other side. The reason being is if you do a mesh on this whole thing, you will not necessarily get a symmetric mesh, and most of the time you will not get a symmetric mesh. Okay, and because mesh is basically is just find the spatial coordinates of the model, then just go around it. So once you split in half, it'll force the mesh to be symmetric. Okay. All right, now split body is the command we need, and we have two bodies. Okay, and sometimes if you didn't hide the 3D handle, you want to make sure you also pick those two mid surfaces. It's okay to split those 3D handles in half because we're not going to use them anyway. Alright, so pick the mid surfaces and choose a new plane as your tool or as the cutting plane. And this face will be XY plane, so which has Z as a normal. So you can take a look at the plane and say okay. And once you do that, then it's split in half, and you can't really tell except the line there. If you hold long enough, you can pick the top surface, the top half. So as you can see, I can actually hide that top half. Alright, so that's all for the handle. Then for the blade part, okay, first we need to split this into two parts. Okay, so we want this bottom half. Let's hide this first. The bottom to be a sheet body. So we need to cut this so we can find a mirror surface on that. And again, that's split body. And this time we need to split this one. We need to do this one by one. And we would like a plane that's perpendicular to XY plane, which is sort of like cutting from this edge. Okay, a vertical plane that goes through this edge, and that will be a new plane. And how we find that plane is we use this at angle method. So this new plane will be vertical, which means it's 90 degree to this plane. Okay, so we can pick this as the reference plane, and also pick a linear object. That'll be this edge, and our new plane will be 90 degrees to this horizontal plane and on this edge. Okay, if you take a look, then we'll do apply. So right away it gives you different color on those two parts. Now we rotate to the other side and do the same thing for the other blade. Okay, so horizontal plane and go through this edge, 90 degrees. Okay. Alright, so the top portion of the blade will be 3D texture, and the bottom we need to find the mid surface. So mid surface again is for those two. You might be able to find mid surface for two parts simultaneously. Okay, so looks that works, and that'll be all for the idealized part. So before we go to the FEM, you want to make sure everything is showing on the screen. So let me try a little bit. If I have things hidden, well, they're still there. That's fine. But just to make sure, we're going to have everything shown in the idealized part. We'll save the idealized part, then go to the FEM. Okay, so once you get into the FEM, there was a information window that says, okay, we just made some cuts, generated some more polygons, which is here. You can tell from the icons they are different, those two and the bottom two. Okay, those are the faces. Then we can hide everything, just show whatever we need to mesh it. But before we mesh, okay, and you notice this is actually multiple faces. It's not a single face. And when you do a 2D mesh, it'll actually, if you pick everything, it'll actually generate one whole uniform piece of mesh. But sometimes, to make sure, you can merge the faces, the polygon faces. So we have this merge face command. Okay, we have two options. First, one option is you can move the edges between two faces, something like this. And another option is just pick any face you want to merge. Okay, I'll box select everything, and if they are within this angle, then it'll merge them together. And pretty much your model should be within that criteria. Then we can do a merge face for the other handle. So notice I only did the merge face for the top half, okay? Because we're only going to match the top of the handles. And sometimes it's hard to find which one's which. You can right click and then rename the polygon. Okay. This is only 14 polygons. If you have a complicated model, you definitely want to rename your parts, the polygons. And that's for the handle. Then we have two pieces of the blade. So those are the blade the sheet body portion. Now we have that too. Okay. You can name it whatever you want. Then we're gonna start doing the mesh. Okay, so first for the handle, and by the way, everything is in the slides. Okay, so for the 2D mesh in this model, everything will be the same. That'll be the type will be C_4. The size is 0.05 inch. Okay, so let's find the handle, and then find 2D mesh. And you can't use 2D mapped mesh because this is not very regular geometry. You can try it, but Next doesn't like it. Okay, this is for the first one. Sometimes you can just show results if you like. Okay, and that's the results. And that window, the warning just said this piece of mesh is not a very good quality, but it's fine in this project. Okay, then we'll mesh the other one. Just say okay. So sometimes it's not there. So even though our cat is exactly the same, you can see the mesh is different. The one on the left had a warning and the one on the right didn't. So you can tell the mesh is really not very consistent, and it might be able because the position of your cat. Anyway, so that's the mesh for the handle, and they're in those two collectors. Then we'll go and mesh the blades. You can hide the 2D meshes, and again mesh this piece, and also you want to pick that little corner. Okay, that's because of the draft that we did on the blade. Well, also okay, 0.05, because they're on two different polygon faces, they should be able to generate two different 2D meshes, but apparently not. Then we'll just do it one by one. Okay, deselect the other piece. Then okay, that's one piece. Then we'll mesh another one, and that put back into the first collector. So how do we make this into the same collector as that one? You can drag this piece of mesh into the other collector. It's like you're dragging a file in Windows between folders. Okay, and that's pretty much it for this lab. If you want to, you can change the name of the collector. I think the first one is on the left side. So if you match the color with our CAD, the left one is yellow, then the right one is red, and that's the blade. Okay. So you really only have two different kinds of 2D mesh. Okay, and if you want to change the color, you can edit display. Then there's option you can change the color, and you can show the thickness visually. Okay, usually what we assign a thickness to a 2D shell, you will not be able to see the thickness. You can, however, turn it on in this edit display. It'll show the thickness of the mesh. So that's all for this lab. Okay, the next lab we will reflect those two pieces to the other side, and in that process you have to make sure you don't generate duplicating nodes along the edge. Alright.